Variables are an important issue in science and in psychology, and so let's talk a little bit about them and the different types of variables. Constants is the place to start, though, because they are going to contrast with variables. Constants are measurements that are the same from observation to observation. Now, constants are very common in the physical sciences, so if your question is, what is the boiling point of water at sea level? One careful measurement gives you the answer. You don't have to do the experiment 50 times. You just have to do it once. One careful measurement will answer the question that you're posed. So the physical sciences, often we're dealing with constants, but in the behavioral sciences, we're often dealing with variables. And that's when measurements change or vary from observation to observation. So if we ask the question, how does Ritalin improve attention? What we're going to find is, and we can all think about it if we just did this thought experiment quickly, is that not everyone starts at the same place in terms of how attentive they are. Not everyone is affected the same by drugs that improve attention. Not everyone understands the instructions the same, et cetera, et cetera. So we're going to get different measurements when we ask questions in psychology from observation to observation, so we have to deal with this. The problem in the behavioral sciences is one of variability. Variability can be a good or bad thing, depending on how you're looking at it. So let's talk a little bit about that. We think that there are a number of main sources of variability. Why do scores vary from observation to observation? Well, that's what we term the sources of variability. The first one is that there are individual sources of variability, that people are different. If we're measuring attention, some people are more attentive than others. But if we ask people to do something, some people understand the directions better than others. So that's also a source of variability. The second source of variability that's really important is the conditions that we apply or impose on people in our experiment. So if some people get 10 milligrams and other people get 5 milligrams, that's going to produce differences, maybe, possibly, in attention. So the experimental conditions that we impose is the source of variability. And the last source of variability we call random sources. These are unknown sources. Does the moon affect our attention? Well, probably not, but what about hours of sleep? I mean, what if some people come into our experiment only having slept 4 hours the night before? What if some people are eating very poorly? That might affect their attention. What if people are exercising more than others? That might affect their attention as well. These are random sources of variability, and there's something that we need to talk about and deal with. Now, let's say that we do an experiment. Okay, this is our experiment, and just for argument's sake, this is what we're going to do, and we're going to talk about some of the issues here in this experiment. So our experiment is we want to know if Ritalin improves attention. So we gather 20 college students, and 10 of them with attention deficit hyperactivity disorder, they get a blue pill, and 10 students without ADHD get a red pill. So now, the reason they're blue and red is that one of them has Ritalin in it and the other doesn't, but I don't know which ones are blue, and I don't know which ones are red. I don't know which one has the Ritalin in it, but this is what we call a blind experiment. I mean, both the subjects don't know what they're getting, and I don't know what they're getting either. Somebody else has done this blue and red stuff for me. So one of the pills has Ritalin in it and the other doesn't. It's a placebo. So 30 minutes later, we give them an attention test. In this case, it's a signal detection test. In a quiet room that's heated to 70 degrees, between 11 a.m. and 1 p.m., around lunchtime, the test is on a computer, and we have one set of overhead lights on. Okay, so that's the experiment. That's what we're going to do. We're going to give these students Ritalin, and then we're going to test their attention 30 minutes later. Okay, so what are the variables in this experiment? Well, the independent variable is the thing that we control. It's the variable of interest, okay, to the experimenter. Now you might think, oh, attention is our interest, but that's not our interest. What we're interested in is the effect of Ritalin. So when we say the variable of interest, the question we're really asking is, what is this variable's effect? Our interest is not on attention, because we're not asking what is the effect of attention, that we don't care what the effect of attention is. We don't care. That sounds funny. Our interest is on Ritalin. What is the effect of Ritalin on attention? We don't not want to know what the effect of attention is on Ritalin. We want to know what the effect of Ritalin is on attention. Yes. So our independent variable here is Ritalin, or is drug. Our dependent variable, or a dependent measure, is the thing we measure to determine the effect. It's the attention test. It's the thing that we conduct statistics on. So the outcome of the test we think is related to attention, which we think is going to be driven by Ritalin or not. Okay, so that's our independent and dependent variables. Now, there are other variables that we control. Okay, in the experiment, we control the dose of the drug, we control the temperature of the room, we control the form of the test, we control the illumination, we control the time of day. If you remember back to our experimental design, what we did was we did it between 11 and 1 p.m., we did it in a quiet room, we did it on a computer, we did it in a 70-degree room, we did it with only one set of lights on. Those are the features of the experiment we control. Okay, now there's features of the experiment that we don't control, and we call those extraneous variables. Extraneous variables are variables that might affect the dependent variable but are not controlled by the experimenter, like how much sleep did each participant have the night before? What are their exercise habits? Did they have what is their diet? Did they have any drinks that day, like a 1-hour energy shot? Did they play video games before coming to, did they have class before this? We don't control all of those variables. Those are extraneous variables. Now, we don't worry about extraneous variables. The reason we don't worry about extraneous variables is that we assume that their effects will be randomly distributed across both groups. If some of our participants drank coffee before our attention test, we assume that roughly equal numbers of those people will be in each group. Okay? Just by chance, yes, it might be that, if we had 5 out of 20 drink coffee, we're assuming that roughly 2 or 3 in each group will have drank coffee. Now, if that doesn't work out, then we're kind of screwed. But we assume that these extraneous variables are sort of equally, their effects are equally distributed across they'll be randomly distributed across the groups. Now, we might want to go back in our next experiment and say, please don't drink coffee before the test, because that might have an impact, but we're not going to be able to eliminate everything. Okay, and that's the second point, is why don't we control all these variables? Because it's just too difficult. It's too costly. And where does it end? Do we have people that come in with the same colored shirt on? Do we have people that live in the same dorm? Where does controlling end? We have to allow some things to vary. We're dealing with human beings after all, and we're going to assume that they create random sources of variability that we can control statistically. Okay, now there's other ways to do this experiment that might be better than that, and those we'll go on from here. Now, what's especially troubling with extraneous variables, though, are what we call confounded variables. Confounded variables are extraneous variables that co-vary with the independent variable. That means that if the independent variable changes, the extraneous variable changes with it. And that's a confounded variable. Now, the problem with confounded variables is that they render the findings of a study absolutely meaningless because there's an alternative explanation. If you notice in our design, we had a confounded variable, and that is everybody that got the blue pill had ADHD. So the difference between the blue and the red pill was confounded by the fact that of diagnosis, or the variable of diagnosis. If the red pill led to higher attention scores, was this a result of the pill or lower scores in the blue pill group because of their ADHD? We have no way to rule that alternate explanation out, and it renders our findings meaningless. Even if we do find an effect there, we don't know whether it was because of the medicine in the pill or the fact that we studied a whole group of people with ADHD and one that didn't. So diagnosis and drug assignment were confounded. And we got to do a better study than that. Okay, so hopefully that helps a little bit with defining variables in science and what confounds mean, what dependent variables are, and so on and so forth.